Hello all, welcome to part 2 of the SecurityTube Metasploit Framework Expert course. In this video, we will explore the need for why we need Metasploit, right? Which is a fair question to ask if you're doing a course on it. So this video is part of the SecurityTube Metasploit Framework Expert course cum certification. If you're interested in taking a certification, please visit securitytube.net/smfe. SecurityTube certifications are currently being taken by students from over 25 plus countries around the world. And this video, along with the entire course material, is going to be distributed free online in line with SecurityTube's vision to provide quality yet free InfoSec education for one and all. So enjoy the course material, feel free to watch it, distribute it, and if you feel like taking a certification, definitely consider us by visiting securitytube.net/smfe. Okay, so the lesson lab setup for this video remains exactly the same as the previous one. And where we left off in the previous video was the challenges one had with using individual exploits. So we had downloaded the RPC decom file, compiled it, run it, we broke into a system vulnerable to it, and what we really saw was that, hey, if we had to really kind of bring together exploits for different operating systems, different services, customize them, manage them, update them, it's a nightmare, right? It's almost like a full-time job. And this is where not just the customization of the exploits, but also of the payload, which is what do you want to do after you break in. Now, to make sense of all of this commotion, what we really require is a framework which can take care of all of this and allow us to use it with a great deal of flexibility. Enter Metasploit. So the Metasploit framework has been around for quite some time. It was written by H.D. Moore, I think around 2003, and was later acquired by Rapid7. Now the best thing is, even though it was acquired, the framework still remains open source and free for use, which is fantastic. And this framework can be used for penetration testing, exploit research, and also to develop IDS signatures. The framework is open source and written entirely in Ruby. I mean, personally, I wish it was written in Python because I love Python more, but hey. Okay, so the Metasploit framework has tons of stuff, over 770 tested modules for exploits, payloads, encoders, and whatnot. The best part is it allows you to plug and play different exploit payload combinations, right? And has a ton of other features we will discuss as we move along the course. Now, what I want to show you is a lot of activities which you previously did with other tools can also be done with Metasploit. So as an example, I'm going to do a TCP connect scan using Metasploit. Now, for anything apart from exploitation, we know we need to use auxiliary modules in Metasploit. We'll come to the different kinds of modules and their functionality in a later video, right? So what we are going to do is we go back to our backtrack instance. So here is our vulnerable Windows XP machine. Here is our backtrack instance, and basically what we want is auxiliary scanner port scan TCP. So I'm already here, use auxiliary scanner port scan TCP, right? Now let's quickly look at the options, and as I had mentioned, everything which is required set to yes needs to be filled out. Now let me just take a small subset of ports rather than doing it for all ports. So let's just take the first 500 ports, and I'm going to set our hosts, which is remote hosts, to 192.168.1.150. Now, people who have never used Metasploit, what we are doing is we are configuring the scanning options with which we are going to do a remote port scan on our Windows XP machine, right? So most of the times the different options are listed here when you do show options, and what you need to check is this column called required. Anything which has yes set to required is mandatory. So ensure that either you are happy with the current default setting. If not, you can change it to anything else you require, right? Ones set to no are optional. So as an example, the interface through which the packets need to be sent out. Now, what we've done is we've set the ports and the host, and now let me make this multi-threaded by setting threads to 10. Now I could again hit a show options just to verify that all the input which I just mentioned is now configured in the module. Now in order to run this module, all I'm going to do is hit the run command, and if you notice, it gives me a list of open ports already. 139, 135, still trying, and then 445, right? So this is a quick replacement, if you like, for Nmap. However, truth be told, Nmap has tons of features which currently is not there in any auxiliary module. So Nmap has its own functionality, utility, and in the service fingerprinting and port scanning game, it's a class apart, right? What I wanted to show you is there's a lot of functionality in Metasploit which most people don't use and which you could leverage, let's say, in case Nmap is not available on your system for some weird reason, right? It should be available all the time. Okay, so we just did the port scan. Now let me go back to our slides and see what's in store next for you guys. Okay, so now what I want to do is replicate the same RPC DCOM vulnerability which we had taken in the previous video using Metasploit. Now Metasploit houses tons of exploits, right? As we said, the number of exploits is over 800. So how do you find the right one? One is you remember the actual module name and use it directly, or you can use the search command. So in this case, I'm going to just do a quick search DCOM. So let me go back out of the context and back to my regular parent console prompt, and let me do a quick search on DCOM. So this is now going to give me all modules which have anything related to DCOM mentioned anywhere. Right, so this takes a bit because you need to search through all the modules. Let me sip a little bit of tea while then. I love making these videos, so hope you're enjoying them as well. And I take my own sweet time to make sure we go extremely slow. So hope once again it's not too slow. So this is the vulnerability we're interested in, right? MS03026, which you remember I had mentioned in the previous video. So this is what our victim is vulnerable to. Now if you're asking a question, hey, if you already know what your victim is vulnerable to, where's the fun, right? So we'll come to how to do things like auto detection and what vulnerabilities could be possible and all that in later videos, right? We'll go slow. Let's take small baby steps towards a larger goal, right? Okay, let me do a quick show options. So what I need to fill up is our hosts, right? Which is the remote computer. Our host 192.168.1.150. Here you go. And the second thing, if you remember, which I talked about, was the payload, which is what happens after your exploit runs and succeeds. So in Metasploit, there are tons of payloads. What I'm going to do is select a payload which mimics the behavior of a remote command shell, just like in the previous video. So I'm going to say, hey, Windows right? And then I'm going to do shell, and it gives you a lot of options. I'm going to just say shell bind TCP. So this is going to go ahead and bind a command shell on a TCP port in the victim, right, after the exploit succeeds and our payload runs. Now you can also customize the payload. So as an example, the L port, which is the local port on the victim where the payload is going to run, is port 4444, right? And what this means is that if the payload succeeds in running, this is the port where the exploit code is waiting for us to connect to it, right? Now, in many cases, you may also have to set a target. What I mean by this is, let's say you have the same vulnerability, however, the way in which we exploit it, or something called offsets, could be different for different operating systems in question, right? We'll come to all of those complexities a little later. So there's just one universal target which is fantastic, which is it works for all operating systems which are vulnerable to the current problem. So at this point, all we are going to do is hit exploit, right? So here goes, we hit exploit. It says sending exploit, and awesome. If you notice, we are back exactly to the same command prompt which we got in the previous video. So Metasploit launched the exploit succeeded, our payload ran, we got a command shell which was there in the remote computer, we've connected to it, and this is what we get, right? You could again do the whole thing which we did in the previous video, do a quick gooder, type out confidential.txt and whatnot, right? Now let's exit and see what happens. So let me bring our Windows XP machine in focus just to prove that it's not stealthy. We can do a netstat -n, and you would notice that the attacker machine's IP address is showing up. Let me go back here. In the previous video, if you remember, when we did exit, there was an error and the machine had to reboot. Let's see what happens now. Right, exited, fair enough, abort session. Let's go back here. Do you notice a reboot? Do you notice anything else which is going wrong here? So what this means is that the exploit which shipped with Metasploit is doing a good cleanup to ensure that the machine is still in a state which allows it to run comfortably and is not basically in a state which requires it to reboot, right? Not just that, in the case of many exploits, depending on how stably we have exited after finishing off our execution of payload, you could actually exploit it back again. This is fantastic, right? And this is where the power of the framework comes in, because the guys who are coding all of these exploits, making all of that plug and play functionality, are also taking care that the exploit is stable enough to ensure that the victim or anything else you're pen testing on is left unhurt after the exploit runs, right? Awesome. So let's go back to our slides. Right, so we set the payload, we exploited the system. Now you could use more exploits as well and try things out. So as an example, I could actually use the net API exploit for SMB. So let's say I go back here, take a step back, and do a quick search for net API. What I'm trying to show is the quick flexibility with which you can just use exploits rather than having to do Google searches, figuring out what the exploit code is, if it is compatible to what you want to do, and all of that which you would have to do in the previous case. You should also get a coffee or tea if you start watching my videos. They are long. Okay, so I'm going to use the one which was discovered in 2008, which is the MS-08-067, right? Let's use this one. Go back up here, quickly look at the options. We need to set our host, right, to 192.168.1.150, and then I need to set my payload just like in the previous case. Should be Windows shell bind TCP, right? Again, I do a quick show options. All the default options are here. If I wanted, I could actually change the L port in this case to, let's say, 6000, right? Because 4444 is almost like a little fingerprint port for Metasploit, to be honest. Okay, and here we go. Right? Fantastic. Here you have, again we have our little shell, and this time if you had done a netstat here, you would notice that port 6000 also appears to be connected to 1.10, right? Awesome. Now what I really want to also draw your attention to is, even though the attacker has broken into this Windows XP machine, there is no perceptible way the user can currently find out, right? When things could magically happen, right? Like files could appear and whatnot. Let me just put this in. So let's say I actually go to C drive, right? And here it is. Let me change to C drive. Then I could actually echo something saying hacked into smfe.txt, right? Once I do that, and if I look at my Windows XP machine, you would notice a new file called smfe appears, which has the word hacked in it, right? I could also delete, remove files and do whatever I want, right? So let's say I remove dcom.c, I remove hacked.txt, and I remove smfe.txt, right? All of this works perfectly, right? All those files have been removed. And I can also make modifications to existing files, which is echo hacked to confidential.txt, right? If I go back here, there you go, right? The word hacked has been added in the end. Fantastic. So again, I can comfortably exit, and the remote system seems to be as stable as ever, right? Let's go back to our slides. So you could actually choose other exploits and try it as well, depending on if your system is vulnerable, right? Very important. The previous time when I run the Metasploit Mega Primer, a lot of people complain saying, hey, I run the DCOM exploit, no shell, no shell love. So it'll only work if the victim Windows XP machine is vulnerable to that specific vulnerability. Now, if you have a problem with getting all of these vulnerable machines, you can choose to get access to our labs, which has a ton of these vulnerable machines, which you can play around with, right? That's the shameless marketing pitch. No, the labs are good. Okay, so now we come to the next part, which is same exploit but different payload. Now, in all the previous examples, what I did was I was just getting a remote bind shell with which I was communicating, right? Now, what if I want to take the same net API exploit but create a user on that remote computer and just exit? I don't want a shell, I don't want anything to happen, I don't want to communicate with the remote computer, I just want to create a new user, right? How do I do it? So let me go back to our backtrack machine. Now, here's the best part. I'm still in the MS-08-067 exploit, And if I look at the options, do you notice currently the payload is Windows shellbind TCP? All I'm going to do is change the payload to Windows add user. And now I'm going to go up there, do a quick show options, and at this time you have a different set of payload options, right? Let's not worry about the exit function for now. We'll take that up later. The username and pass. This is the username password combination with which a new user will be created on the victim Windows XP machine if our exploit succeeds and the payload runs, right? So let me just run it without any modifications to the payload. One word of caution, though most of the times you can rerun the exploit on the vulnerable system, because Metasploit would kind of leave it in a stable mode after all the cleanup. In some rare cases, it might not work over and over again, right? In which case you may just have to reboot your lab machine. Anyway, so it is trying to exploit, trying to do something interesting, and it just exits, right? It says exploit completed, but no session was created. Now to verify if a new user was created or not, I can just either look through the control panel or I could just log off. Right, and if you notice, now there is a new user called Metasploit on this system, right? If I do a little full screen for you, there is a new user here called Metasploit. Now this is how you can actually mix up the same exploit with a different payload. Now you can clearly imagine the power of doing this, which means basically we've decoupled the exploit and the payload, and now we can mix and match them, of course with some basic limits which we'll talk about later as we require. This is one of the key power the framework gives you. Right, I already did the add user one, which you should try out as well. So now further limitations, right? Now what we figured is, let's say you wanted to do a bunch of tasks, which is you want to delete remote files, you want to add new files, you want to make modifications, you want to add a new user, you want some other interactivity, you want a remote VNC session, you want to take screenshots. Now, how do you do this with a single payload, right? Payloads have always been created with a specific singular task in mind. So it looks like what we would have to do is then chain various payloads and run them. Doesn't solve the problem, right? Even if we could do it, that would be exceedingly long. Second, once any payload executes, there is no way we can add further functionality to that payload, right? Now, at the very same time, what we want to do is ensure that whatever we run on the remote system does not trigger any alarms of any kind, right? Which is the AV should not complain, there should be no file written to disk. At the very same time, you know, whatever we do should just happen in memory and a bunch of things. This is where what we really need is a payload which avoids new process creation, which is fantastic, because now when a user or any other tool looks at the list of processes, it would not find anything new, right? Second, what this basically means is it can somehow run quietly in the exploited processes context while still allowing the exploited process as much as possible to run as usual, right? Third, it should not create a file on the system, because this is a big red alarm for your antiviruses and host-based IDSs. Finally, you also want a payload which allows you to extend its functionality at runtime based on what you see on the remote system. What I mean by that is, you've broken into a Solaris system, and then you figure out that you need a lot more functionality than what you just shipped there, right? So in this case, the payload needs to be flexible enough to allow you to extend its functionality at runtime whenever required, right? Last but not the least, the payload itself should be some kind of a platform where you can write your own scripts and extend whatever it can do. So this is a huge requirement, right? It's almost like you're expecting the world out of that payload. And this payload is basically what the Meterpreter is, right? So the Meterpreter in Metasploit is this special payload, gift from God, which does all of this and much more. So we'll look at Meterpreter in the next video. This is all for this video. This is part of the SMFE course pen certification. Please have a look at securitytube.net/SMFE if you would like to get certified. That's all for this video. Thank you very much. Please do leave your comments behind if you've had the patience to watch till the end. And this video, along with the entire course material, is going to be distributed free online in line with SecurityTube's vision to provide quality yet free InfoSec education for one and all. So enjoy the course material, feel free to watch it, distribute it, and if you feel like taking a certification, definitely consider us by visiting securitytube.net/SMFE. Okay, so the lesson lab setup for this video remains exactly the same as the previous one. And where we left off in the previous video was the challenges one had with using individual exploits. So we had downloaded the RPC decom file, compiled it, run it, we broke into a system vulnerable to it, and what we really saw was that, hey, if we had to really kind of bring together exploits for different operating systems, different services, customize them, manage them, update them, it's a nightmare, right? It's almost like a full-time job. And this is where not just the customization of the exploits, but also of the payload, which is what do you want to do after you break in. Now, to make sense of all of this commotion, what we really require is a framework. Personally, I wish it was written in Python because I love Python more, but hey. Okay, so the Metasploit framework has tons of stuff, over 770 tested modules for exploits, payloads, encoders, and whatnot. The best part is it allows you to plug and play different exploit payload combinations, right? And has a ton of other features we will discuss as we move along the course. Now, what I want to show you is a lot of activities which you previously did with other tools can also be done with Metasploit. So as an example, I'm going to do a TCP connect scan using Metasploit. Now, for anything, hello all, welcome to part 2 of the SecurityTube Metasploit Framework Expert course. In this video, we will explore the need for why we need Metasploit, right? Which is a fair question to ask if you're doing a course on it. So this video is part of the SecurityTube Metasploit Framework Expert course cum certification. If you're interested in taking a certification, please visit securitytube.net/SMFE. SecurityTube certifications are currently being taken by students from over 25 plus countries around the world, which can take care of all of this and allow us to use it with a great deal of flexibility. Enter Metasploit. So the Metasploit framework has been around for quite some time. It was written by H.D. Moore, I think around 2003, and was later acquired by Rapid7. Now the best thing is, even though it was acquired, the framework still remains open source and free for use, which is fantastic. And this framework can be used for penetration testing, exploit research, and also to develop IDS signatures. The framework is open source and written entirely in Ruby. I mean,